What did the receiver say to the radio wave when its frequency was too strong? Ouch, that mega hurts. Because radio waves are measured in megahertz. Ha ha ha. You've probably listened to radio in your car, but have you ever wondered how radio works? Radio waves are a type of electromagnetic radiation with wavelengths in the electromagnetic spectrum longer than infrared light. Radio waves have frequencies from 300 gigahertz to as low as 3 kilohertz, and corresponding wavelengths ranging from 1 millimeter, or 0.039 inches, to 100 kilometers, or 62 miles. There are 4 main types of radio waves: FM, AM, HD, and satellite. There are 4 main steps in explaining how AM and FM radio work. First, a radio station sends the radio signal, which is picked up by the radio transmitter. Then, the radio transmitter sends out a signal. Next, the antenna on your radio or car picks up that signal. Then, the radio tuner and detector inside your radio filter through all the radio signals they're receiving and pick out the frequency of the station you want. Finally, the radio turns the frequency into sound and information.
Some similarities and differences between AM and FM include the following. AM stands for amplitude modulation, which means the amplitude of the waves is changed to work for the radio station to be detected. FM stands for frequency modulation, which means the frequency of the waves is changed to work for the radio system. AM has a wider range but with worse quality, like how a person yelling from far away can be heard by more people but not as well. FM has a closer range but better quality, like how a person talking to someone who is close to them can only be heard by that person. The range of AM is 535 to 1705 kilohertz, and the range of FM is 88 to 108 megahertz. These are the names of radio stations that you see on the radio. For example, 710 AM is a sports broadcasting station in the western Washington area, while 107.7 FM is a local Seattle radio station. The next type of radio is HD radio. HD radio is very similar to FM and AM, but is a little more high-tech. The HD process of additional bandwidth allows for stations to have different stations within their own station, which is called multicasting. It works basically the same as FM and AM, but has a few subtle differences in the way it gets to you and the information it holds. First, the HD radio process begins with the station combining the analog and digital audio signals with text. Then it compresses the digital signals using compression technology. Next, it sends the package of signals to the transmitter, where the broadcast occurs. There, the signals undergo some interference and multipath fading, minimized by the HD process. Finally, the signals are received at vehicle and home radios.
The final type of radio is satellite radio. Satellite radio is a mix of FM and AM. It serves a broad range of locations and has a very strong signal. However, you have to pay for it. The general idea is the same as AM and FM radio, with a few minor differences. The main difference is that the radio signals are sent up to satellites in space that bounce the signals back to a lot of people. Here are 2 equations that can be used to calculate different aspects of radio waves. The first equation is one that we have used in class, which is the c equals frequency times wavelength, c being the speed of light. The second equation gives us the signal strength over distances. It is the quantity of 4 pi times the distance times the frequency all over the speed of light, and all of that is squared. The example question is, what is the wavelength of 98.1 King FM? Our givens are the frequency, which is 9.81 times 10 to the 7th hertz, and the speed of light, which we defined as 2.99 times 10 to the 8th meters per second. We're finding the wavelength here, and our formula is c equals frequency times wavelength. Once we plug in the numbers into the equation and do all the calculations, we will end up with wavelength equaling 3.05 meters.